So the question that was just asked are these formulas, the cosine and the sine, always going to be the same? Yes, they're always going to be the same. Now, let's try to find the time to the peak. The time to the peak is in the y-plane. So we've always gone for this formula first. And said, hey, initial velocity is 0 at the peak. And done 4.9 t squared equals x. But I don't have t and I don't have x, so I can't use that. So I'm going for my next formula. That one. So I'm going to go VF is equal to VI plus AT. Now I'm going to put in what plane I'm working in, or else I will forget. So right now I'm going to add in my y component just to remind myself that I'm working in the y plane. Look up here. Thank you. Velocity final in the y plane is negative 7.2. Velocity initial in the y plane is positive 7.2 plus negative 9.8 t. What's wrong with this? This is how I would have approached it.
It doesn't make any sense.
Yeah, it does.
How?
This is the final speed. This is the initial speed.
Yeah, but we run those two together. It doesn't equal.
You're right. It equals 0, right?
That doesn't equal 0.
No, it'll negative 7.2 minus 7.2 will give you 14.6.
Oh,
Yeah.
wait.
It doesn't work. Because it
So
should
if
equal.
this is plus, I have to minus it. Yeah, it's going to come out to be 17.4. That'll give me not the time to the peak, but rather what? Think about this for a second. Where are we talking about? If I take a look at my picture, I see that this is the positive 7.2.
Wait, isn't it giving you total?
It's giving me my total time. I need the halfway point. So that's not the time to the peak. This is the total time. So I'm going to erase this. And what do I need to change?
Can you change where the negative 9
Nope. That's the acceleration. That stays. No. Which of these speeds do I have to change? Where am I looking for? Where's my end time? Where's my end time? Final or initial? Does it really matter?
No.
Doesn't really matter. I could change this one to 0 or this one to 0, just not both of them. I'm going to say that this is my initial point and this is my final point, and so my final velocity is at the peak, and at the peak it's 0. So let me just repeat this. I want the time to the peak, and at the peak I know my final velocity is 0. My initial velocity hasn't changed because that's the speed at which I'm being launched with. So now I'm going to do some math. It's plus over here. It becomes negative 7.2, 9.8 t. Multiply, so I have to do the opposite, divide. And the time to the peak is, anybody get it?
73 seconds.
Yeah, something like this, 7273. Okay. Now I could repeat it to the same thing to get the total time. To get the total time, I'm going to use my y-plane as well, and I'm going to say velocity final is equal to velocity initial plus plus AT. Velocity final is negative 7.2. This is positive 7.2 plus negative 9.8 t. Plus 7.2 turns into, what is that? Minus 7.2, and 7.2 minus the 7.2 is 14.2 is equal to negative 9.8 t. Divide by 9.8, divide by 9.8. T is equal to, or we could have just doubled that, 1.46 seconds. Nice way to check it. make sure. So you could have skipped the math and just doubled that. So now I've done this, okay. So my time to the peak is 0.72 seconds, 73, sorry, 0.73 seconds, 1.46 seconds. I still haven't done height or range, so let's go ahead and do that. I'm gonna erase this. If I'm doing my max height, which time do I want? The full time or the half time?
Full time. Wait. What was your question?
To find the height,
Oh.
it's where?
Half time.
Half. So I'm going to use my half time. So I'm going to use distance is equal to, what is it? Velocity initial times the time plus 1/2 AT squared. I'm working again in my y plane, so I'm going to indicate that I'm working in my y plane. So the way to get this right, there's two different ways you can do it. I'm going to do it both ways. I'm going to do it with the initial velocity is equal to positive 7.3, or is it 2? 7.2. I'm going to do it with initial velocity as y. Why can I do it with initial velocity as y? I could do my problem with this is my starting place, or I could do it with this is my starting place. So I could either do it from here to here, or I could do it from here to here. They're both going to give me the same height. Does that make any sense? Because remember when we did horizontally launched projectiles, we did it from here being 0. So if I do that being 0, x is equal to velocity initial times the time plus 1/2 AT squared. This crosses out, and I get negative 4.9 times 0.73 squared. X is equal to, and I have it right here, 2.6 meters. It's negative because it's going down. Let's see if I get the same thing if I do it over here. Okay, so now I'm going to use this. I'm going to say x is equal to velocity initial times the time plus 1/2 AT squared. Distance in the y-plane is equal to velocity initial, which is 7.2 times the time, which is 0.73, plus half of 9.8 is negative 4.9, 0.73 squared. Wow. Positive and negatives get really big here. Okay? So now I'm going to do 7.2 times 0.73. And I get positive 5.256 minus 0.73 squared times 4.9. And I get negative 2.6111, whatever. Since they're different signs, I gotta subtract. Wow. X is equal to negative 2.6 meters. So that doesn't matter. I could start here and go to the peak, or go from the peak to the ground. That's pretty awesome. So now I got my height, 2.6. And I figured out 2 different ways to do it. Range. Whoa, range is a whole nother story. For the range, I better know that I am using the total time of 1.46 seconds. So now I have to do is plug in my handy dandy formula again. Can you see why we did horizontal launch first? Remember, in the x-plane, there's no acceleration in the x-plane. So I'm going to remind myself again that I'm working in my x-plane again. There's no acceleration in the x-plane. So now I'm going to use my initial velocity in the x, which is 9.8. Biggest mistake people make is not doubling the time. And 9.8 times 1.4 is 14 meters. So the range is going to be 14 meters. Not bad. Take a minute, take a look at it, and take a picture of it.
So, are we focusing on the total time or the peak time?
Depends on what you're being asked.
Okay.
You're looking at the peak time for height, the total time for range.
Okay.
How far does it go, the total distance it travels in the x-plane, you need the total time.
Right.
Okay?
The bottom one is for the X, right?
Yeah.
For what she said.
Total time. Well, I use the y components. I just
Right.
doubled it. Okay, now I'm gonna give you a mistake that people commonly make. Ready, Shiv? Are you still taping?
Yeah.
Okay. All right, guys, I'm gonna erase the board and I'm gonna give you a common mistake that people will do.
Mukina.
Okay? Many times when people
it's
read
right
a
here.
problem,
Yep.
they will take a look at the problem and they mislabel things. So many people don't understand when they say that, let's just say, a football is kicked with a velocity of 12 meters per second at 32 degrees and travels 36 meters. When they set up their triangle, unfortunately, they don't really take a look at the numbers. Here are my numbers. This is a velocity, this is a distance. I can't put them on the same triangle. A lot of people will then give me a triangle that often looks like this. And then they'll start to work out their components of motion, and they can't understand why they're getting it wrong. What's wrong with this?
So, if you were going to draw the triangle, you would only have 12 and 30 if they were in the triangle?
Correct, because it's components of motion. This is a distance, this is not a component of motion. This has nothing to do with it. You can't use the 36 at all when you're finding the components of motion. That's a common mistake.
So, do you use that 36 when you put it in the chart and then you have to figure everything out?
Correct, you use the 36 when you put it in a chart because really what they're saying is it goes a total distance of 36 meters. All right? But it's not the component of motion. You're still going to have to find your velocity in the x, and you're still going to have to find your velocity in the y. The 36 is not part of that triangle, so don't make that mistake. The triangle has to be all velocity, not velocity and distance. Okay? All right, thanks, Shiv.